Uh, Good morning, ladies and gentlemen. I will try to present you something a little bit different. This is knowledge infrastructure for smart cities. The beginning of this research begins by the comparison with companies. You know, in companies, this is very common now to use what they call business intelligence. And the idea, what can we do for city management, urban planning, smart cities? Okay, this was the beginning of this research. But one of the main difficulties is how to encode urban knowledge, geographic knowledge. So I will try to explain you how to do this kind of thing. The first thing is that we are in the context of the knowledge society. Knowledge society has different meanings, but I don't have time to examine all those definitions. But anyway, we will say a few words regarding knowledge in smart cities and territorial intelligence, especially rules, geospatial rules, because you know, as knowledge, rules are the more important aspects, and I will show you how to encode some rules. And after, I will try to finish my talk by presenting some aspects regarding knowledge infrastructure. Something this is very important is now this philosopher was saying that knowledge now is in infrastructure. It's not only roads, power lines, you know, internet and so on, but knowledge is also an infrastructure, and the problem is how to organize this infrastructure for smart cities. The first thing is to define what is knowledge, okay? We are facing a very important societal transformation from, let me say, agricultural society, industrial society, and now we are calling it knowledge society. The first thing is to define knowledge. Okay. In computing, we have this kind of definition. The first level is data, raw data. It could be numbers or string of characters. Information in when this is the meaning. For example, George Washington, okay, this string of character, but in reality, this is not the guy, but the name of an avenue, okay? This is information. Knowledge is, for example, if the traffic light is red, I have to stop. This is the knowledge. And what we call wisdom is to follow the rules. This is what we call wisdom. This is not wisdom in the sense of philosophers, you know, but you know, this is to be coherent, consistent with rules we have to apply. Another example is this cake metaphor. For example, data. Data for this is this molecular components. When you are eating a cake, you don't care regarding molecular component, but this is data, okay? Oh, sorry. Information, the list of ingredients. Okay, this is a little bit more interesting. Knowledge, this is the recipe. How to make, and the wisdom, you know, is something is missing. So I decide not to make this cake, or I have invited somebody and he's loving this kind of thing. I will prepare. So this is wisdom. Well, regarding geographic knowledge. Regional college has given some definition regarding geographic knowledge. And myself, I decided to extend a little bit this definition. This is to explain, to manage a city, to monitor, to plan a territory, and to innovate, taking ideas from other territories. This is another definition of knowledge, a very common definition, is information which is able to be used to solve a problem. This is knowledge in computing. And so here, it's not only to solve urban problems, but yes, to solve urban problems, but with different visions, you know, to plan, to explain, and so on. Regarding smart cities, okay, there are several definitions. Carlo, Ratti, for example, is defining a smart city with a list of characteristics. This is one of the definitions. Okay, here is this several other definitions were given. And also, I like this, this definition. Myself, I prefer diagrams. I don't like narrative explanations. I prefer diagrams, and this one is, for me, is very clear. Smart city means smart mobility, buildings, energy, governance, citizen, healthcare, technology, and infrastructure. This is one of the definitions. Or an extension of this definition is given by, okay, but I have no time to explain everything. Regarding territorial intelligence, business intelligence, and apply to our problem has different meanings. Some people are speaking about spatial intelligence. Some people are using city intelligence, geospatial intelligence, territorial intelligence. There are different versions, but it's more or less the same things. In reality, this is something, combination of social, societal, environmental, and economic, And I will propose my own definition of territorial intelligence. We need first a territory. In this territory, we are trying to combine artificial intelligence and collective human intelligence, okay? And one of the goals, this is sustainable development. So this is, the more important is how to combine artificial intelligence and human collective intelligence. And this is the challenge and the scope of my research. Well, in order to structure geographic knowledge systems, we need to have a good description of the territory, description of its dynamics, the projects, and this is an example of a knowledge-based system. So the more important are geographic rules. I will explain you what I mean by rules, okay? And the core of this presentation will be devoted to rules. For that, we need to have geographic objects. Geographic objects means, for example, buildings, parcels, monuments, roads, and so on. Geographic relations. It means relations between the things. It could be topological relations. It could be some other relations we can have between objects. Ontologies is something very important. Ontologies, this is an organization of the vocabulary in order to define something. Okay, and so for those who are not familiar with ontology, this is not so simple to explain you what it is, and I need a minimum of 1 hour to explain you what is exactly an ontology. Well, we need to have a gazetteer. A gazetteer, this is a list of place names. And for a lot of applications, we have difficulties regarding place names. Look at this city. What is the name of this city? You have several variants. Officially, this is Zertobgenbosch. Excuse me for the pronunciation, okay? But sometimes the word Den Bosch is using. The day before yesterday, at the station, the train station, you have to put the first letter to get the ticket. I was looking for apostrophe S. It was not in the list. I asked somebody, you have to press H. Oh, okay. So the name in this machine, this is simplified, okay? There is also a French name, Bois-le-Duc. And in some places, in some maps, you see the French name, not the Dutch name. So, and so on. You have some problems regarding the names, and in a lot of places, you have problems. It means, from a computing point of view, you can make a decision. We will use this name and no more. But in reality, for humans, we are using several variants of names, and we need, in systems, to combine those variants. And one is one of the challenges we have to face. We have mathematical models, okay? They are representing some economic models, but we can have mathematical models for floods, for example, for pollution, diffusion, and so on. You know, we need to integrate this kind of thing. We have geographic structures, because, for example, here, in some objects, urban objects are very complex structure. Look, for example, at an airport. An airport is one object, but in this structure, you have several terminal, landing tracks, some other building, parking lots, and so on, you know. So you have several, it's something a little bit more complex. And also, we need external knowledge. This is something very important. You know, in urban information systems, usually you have a jurisdiction, you know, and you have no information outside the jurisdiction. Remember, in the last maps, in the previous century, maps like that, you have a country, but you have information outside the country. Okay, we are filling the full rectangle. But now in computing, you have, okay, for example, for the Netherlands, the semantic of the boundary with the sea and the semantic with Germany is totally different. Okay? But in computer maps, in usual computer map, nothing. Okay? But for a lot of things, in order to make reasoning and to ensure the continuity of reasoning, we need to have external information. External information could be in the hinterland, okay, at the vicinity of the country, the city, and so on. But also, it could be outside knowledge. For example, coming from something which is important, this is, you know, is technology watch in companies. But in a few cities, there is something like technology watch. Particularly in our cities, there is technology watch, okay? And this is, perhaps this is very important. And also there is no sociological watch. What are the experimentations in other cities which can be imported in our city, okay? And this is external information. Now regarding projects. It's, for example, where to build a new airport, new hospital, what are the constructions, the best way, and so on. Okay, so the structure will be as follows. We will have a geographic knowledge base, a geographic inference engine, an input, a project for the city, a new road or something else. In the output, we can have feasibility report, spreadsheet, alternative maps, 3D models, columns, and so on. Columns, you know, for those who are not familiar with this concept, this is a way to represent schematization of a territory. The aspects are more important, you know, and sometimes it's in some places you are presenting atlases. It means a huge set of maps, but you want to try to, in a single map, to integrate the more important aspects, to simplify, to schematize. Regarding rules, in business intelligence, there are two kinds of rules. First, now in computing, rules must be considered as a first-class citizen. It means in a lot of business applications, they are based on rules. Your wages, for example, your sheet for your wages are based on rules. You are not aware, perhaps, this kind of thing. This is no more a very complex COBOL program. No. This is a set of rules. As soon as the government modifies some laws, we are modifying as one of the rules. And two kinds of rules: if, then fact, if, then actions. If, then action, it could be another action, it could be a human action, a robot action, okay? But if, then fact, it means we need to modify something, to modify an attribute of something, or to, and so on, okay? And they are all based on logic. But regarding cities, on geography, we need some other aspects. We need to integrate geometry and topology. computational geometry. Look, for example, a system, on all GIS systems, you have a lot of functions coming from a computational geometry. And we need to combine. And something which is not very common, I asked to a lot of colleagues working on logic. And for them, for mathematicians, I mean, mixing logic and computational geometry, they are afraid. Okay. Anyway, I have decided to go in this direction and to try what I can do by mixing those two different languages to different kind of, let me say, parochialization of in math. Well, to explain more, let's go to explain, to give a set of rules in series. For example, if a lane is narrow, make it one way, except if it is a cul-de-sac. When planning a metro line, move underground networks, no parking, no business. Okay. Each building must be connected to utility networks. Council flats must be connected to urban heating systems. Is a crossroad is dangerous, install traffic lights, transform street pedestrian precincts, commercial mall, and so on. At the vicinity of an airport, limit building heights. Those are example of rules. Okay. For a big plant is closing, a vicinity, there are a lot of rules like that. I have no time to explain all of those rules, but in my books, some of them are explained. So let's examine one example. This is an example, at the vicinity of an airport. Here, this is an airport. You have a landing tract, and here in this red part, let me say, building height is limited. Okay. Another example. In urban planning, usually when you ask for a building permit, you have to apply some rules regarding your building, the building you are proposing. Depending on the countries, the rule can be different. We can have the distance to the street, the height of the building, and so on. Okay, those are planning rules. Something which is a little, so here in this case, it's a 3D object. Okay, regarding the previous airport, this is only a 2D rules. This one, it could be seen as a 3D rule. We can have located rules. It means in some places we can have some rules, but those rules are only applied in one place. Okay, this kind of thing. Regarding rules, geospatial rules. So they are coming from physical laws, for example, floods, air pollution, and so on. Engineering rules. I was speaking about creating a metro line to move underground networks. Legal rules, standards, best practices, text mining, data mining, and watching. Regarding mathematical tools, logic, geometry, operation research, geometry and topology, and differential equations. Differential equation, I mean, for floods, for example, air pollution, diffusion, they are governed by differential equations. The usage could be for monitoring, forecasting, planning, understanding the past, innovating. Okay. But there are some other aspects. Ancient rules. The problem is that for historical buildings, for example, this one, I suppose this is an historic building, okay? It was organized according to several rules, okay? But sometimes it is in contradiction with new planning rules. But it's a monument, in this case, this is an exception. So, but this building is supposed to follow some past rules. Project, so this is a temporal dimension, okay? The components, objects, natural or man-made, okay? Mountains, buildings, relations, structure, gazetteers, ontology, and sometimes we have to use languages, different languages for some applications. It's important. Imagine you have to make a project for the Danube River. Danube River, this river, a very important river, has different names in different countries. Okay, but in the different countries, it means different information systems, it means different ontologies, and so on. You know, we have to combine everything. So we have to semantics, geometry, and those rules could be mandatory. Well, I have no time to explain those aspects. Okay. So regarding the typology of rules, as I told at the beginning, in business intelligence, if then acts, if then facts, if then actions. Here, collocation rules, two things are located at the vicinity. The creation of a rule, for example, when we decide to create a recreational park, it means we are creating a rule, a zone, in which we will apply some different types of rules. Meta rules, located rules, by location rules. In this case, if there is something in a place, there is a consequence in another place. I don't want to speak about the butterfly effect, but for example, in a big companies, a decision can be made in headquarters, perhaps in America, and it will have a lot of consequences, for example, in this city. And it will have more consequences than a small decision made by the mayor, let me say. For example, I will take this example for historic monuments, okay? And this will be coded like that, as we do in math. The first part, until here, this is the description of the context. It means we have one place in the earth, something, a project. The type is a building, monument. If it is inside, well, inside, okay, in this case, your project is approved or not. Well, so it means here it's mixing computational geometry to define a buffer around the places and so on. Well, regarding infrastructures, okay, you know, there is in Europe the INSPIRE directive. The idea was for data, but in reality this is for information, because it's in this directive, metadata and data are combined. But, so it means, here we have the knowledge infrastructure. The data, connections, sensors. Machine processable knowledge, human intelligence, okay? And we have the governance, okay. Another vision is data infrastructure, human intelligence, which is machine processable, not yet processable language, or some human, now we have a lot of rules, but we don't know, we have no ideas how to encode them, and applications. And finally, the knowledge infrastructure can be used by several in a place. We have a sort of virtual circle, okay, between knowledge, acquisition of knowledge, and usage of knowledge from big data. To conclude this presentation, let me say that knowledge is very important. I have no time to explain all the steps in this research agenda, but the more important is to identify knowledge chunks, and second, to encode them. The first step is to have a list, a textual list, let's say in natural language, okay, or legal language, or with drawings. Because look, for example, for buildings or for airport, it is simpler to make a drawing than to give a text. Well, and after to encode those knowledge, okay, and to build applications, to check the acceptability by different stakeholders, and so on. And thanks a lot for your attention. Yeah, I have a copy of my book just over there.
So thank you for your presentation. Even before I had to show you stop, very good. So I think we also can grant a small question before we resume for the coffee break.
You were afraid by the mathematical formalism? No, no.
No,
don't be afraid by this kind of thing.
Otherwise, I have plenty questions, so I'll raise one about that we were discussing previously about multi-language.
Mm-hmm.
Do you think that is still a challenge, or is it already also solved?
Well, the problem is that in the majority of cities, there is no problem of languages. Okay, I mean, the problem of understanding, you know, different thing. But in several cases, in Brussels, for example, finally there are 3 languages in Brussels: French, English, and Dutch. Flemish, sorry. Okay, and or a city like Basel, and so on. In some countries, in Belgium, for example, or in the northern part of Italy, where they are speaking German, you know, we can have some problem regarding linguistic aspects. For cities, very few cities have linguistic aspects. But for environmental studies, I was speaking about the Danube. You want to organize a plan for alpine regions, the mountains, for example. You know, in this case, you can face some problems regarding linguistic aspects. But if you have very important projects throughout Europe, you have to face those challenges. But it's a particular case. You know, back to ontologies. You know, in the past, I organized a European research project named Towntology. It was a project for doing urban ontologies. And I don't remember, something like 15 different laboratories were involved in this research. Okay, and one of the problems at the beginning is, well, do we organize several ontologies in different languages, or if we do one ontology, for example, in English, and after translate it, you know. But you know, why not? But you know, the concept of is a French autoroute, autostrade, autopista in Spain, you know. There is no concept in English. Perhaps toll motorway. In American turnpikes, you know, but for example, for the city of Venice, you agree this is a city, but you know, okay, he has different vocabulary, okay, and but it's impossible to translate it into English, okay, and if you are using English, we have a very poor representation of those places, you know, and I have a lot of examples like that, okay. For 80% of the problem, this is an interesting solution, but sometimes this is not a good solution.
Okay. Thank you very much. I think we can resume for the break, have a coffee and tea, and I'm sure there will be more questions for the speakers. And thank you all for your inspiring presentations.